Hello everyone, and welcome to Sky Scholar. My name is Steve Crothers. Today I will explore the special theory of relativity, which pervades modern physics and astronomy. In my previous lecture in this series, I presented mathematical proof that the general theory of relativity is invalid because it violates the rules of pure mathematics. I will now demonstrate how special relativity also violates the rules of pure mathematics. Consequently, it has no physical meaning. This, of course, is anathema to physicists, astronomers and cosmologists, but the proof is not complicated and is unequivocal. It involves the theorem of Pythagoras, that is, the right triangle rule, which is taught to everyone in high school. Beyond that, the proof utilizes the elementary geometry of a circle and an ellipse. In both cases, the distance from the origin of the coordinate system to the periphery of the geometric figure is given by the theorem of Pythagoras. Given sufficient knowledge from high school algebraic methods, and if you carefully study the proof I give, you will realize and understand that special relativity is not a scientific theory at all because it is mathematically invalid. Albert Einstein's special theory of relativity was published in 1905 in this paper. I suggest that you obtain this paper, which is available online for free, and consult it in parallel with my video so that you can see for yourself the arguments advanced by Einstein. You will also see precisely where he committed violations of the rules of geometry. This famous paper is verbose and contains strange concepts as to the nature of time, space and clocks. Today, I'll focus on the mathematical foundations of special relativity because its invalid geometry is definitive in proving that Einstein's famous paper is false. His paper is quite long, but there is actually only a very short section in it that bears upon the entire question. The rest of his paper is immaterial. Here is what he says in section 3 of his famous paper. At the time t equals tor equals 0, when the origin of coordinates is common to the two systems, let a spherical wave be emitted therefrom and be propagated with the velocity c in system k. If x, y, z be a point just attained by this wave, then x squared plus y squared plus z squared equals c squared t squared. Transforming this equation with the aid of our equations of transformation, we obtain, after a simple calculation, z squared plus eta squared plus zeta squared equals c squared tor squared. The wave under consideration is therefore no less a spherical wave with velocity of propagation c when viewed in the moving system. This shows that our two fundamental principles are compatible. Einstein refers to two fundamental principles in this quotation, namely his principle of relativity and his invariance of the speed of light. The principle of relativity asserts that the laws of physics are the same in all inertial frames of reference. The principle of the invariance of the speed of light asserts that the speed of light in vacuum is the same for all inertial observers. In the introduction of his 1905 paper, Einstein stated his two principles or postulates in this way. The same laws of electrodynamics and optics will be valid for all frames of reference for which the equations of mechanics hold good. We will raise this conjecture, the purport of which will hereafter be called the principle of relativity, to the status of a postulate, and also introduced another postulate, which is only apparently irreconcilable with the former, namely that light is always propagated in empty space with a definite velocity c, which is independent of the state of motion of the emitting body. It is therefore essential for special relativity that an expanding spherical wave of light centered at the origin of coordinates of Einstein's stationary system be transformed into an expanding spherical wave of light centered at the origin of coordinates of his moving system. Einstein invoked the Lorentz transformation to obtain form invariance of the right triangle rule, which he claims satisfies his two postulates. How did Einstein come to the conclusion that the two wavefronts are both spherical? The answer to this question is provided in this video. It is the key to understanding why special relativity is false. But before proceeding to this proof, it is worthwhile to examine Einstein's assertions about clocks. The fallacy of his strange views relative to clocks is simple to understand. If you consult his 1905 paper, you will find that he defines time by means of his clocks. He then goes on to talk not about time, but about his clocks. Here is what he says in section 1 of his paper. It is essential to have time defined by means of stationary clocks in the stationary system, and the time now defined being appropriate to the stationary system, we call it the time of the stationary system. In section 2 of his paper, he says this: time here denotes time of the stationary system and also position of hands of the moving clock situated at the place under discussion. In section 3, concerning the time tor in his moving system, little k, he says that tor is nothing else than the summary of the data of clocks at rest in system k, which have been synchronized. Clocks can tick and tock at different rates, but Einstein sees this as time passing at different rates. The different ticking and tocking of clocks does not mean that time is passing at different rates, only that the clocks are not calibrated. Now recall that according to the general theory of relativity, clocks are affected by gravity. By that theory, clocks run slower in the stronger gravitational field, so that a clock on the surface of Earth runs faster as it is moved upwards into the weaker gravitational field. Consider an hourglass and a pendulum clock on the surface of Earth. They are both chronometers. As they are raised upwards, they run slower than they do on Earth's surface, so they are affected by gravity. But the effect is opposite to the effect Einstein assigns to his clocks by his general theory of relativity. Now let the hourglass and the pendulum clock reach the height of the International Space Station and place them inside that spaceship as it orbits Earth. Inside the International Space Station, the hourglass and pendulum clock stop completely. Does that mean time has therefore stopped for the astronauts inside the International Space Station? Clearly, time does not stop for the astronauts, even though the hourglass and pendulum clock stop running. So clocks are not time, and they do not define time. They are simply measuring devices, and all measuring devices are invented to measure something other than themselves. Einstein's clocks, however, measure only themselves. There is an element of sympathetic magic in the connection between time and clocks, which generated the irrational character of time and space woven into the mathematics of special relativity. What's sympathetic magic, you might ask? Einstein argues that what happens to his clocks also happens to time, although in his case there is no difference between clocks and time. Manipulation of his chronometric effigies of time is therefore direct manipulation of time itself. In defining time by his clocks, Einstein detached himself from physical reality in his theoretical imaginings. Einstein didn't advance the so-called four-dimensional space-time continuum in his 1905 paper. That fallacious idea was introduced by Hermann Minkowski in 1908 in this paper, which is available online for free. In the opening paragraph of his paper, Minkowski dramatically declared this: "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." But nothing can be further from the truth. I'll not today consider further Minkowski's reformulation of special relativity in terms of his arcane four-dimensional space-time continuum, except to say that he unwittingly preserved the mathematical error of Einstein and presented it in a different format. The essence of the proof of the invalidity of Minkowski's space-time continuum therefore also rests on the theorem of Pythagoras. Minkowski's formulation will be the topic of my next Sky Scholar lecture in this series on the theory of relativity. Special relativity concerns inertial coordinate systems, otherwise called inertial frame. They are coordinate systems that move in constant relative rectilinear motion. That is, they move with a constant speed in a straight line. Most presentations of this theory use the x-axis of a Cartesian coordinate system as the line of constant motion. So I'll also use the x-axis in this video. The mathematical basis of special relativity is a transformation of coordinates from one inertial frame into another. The transformation involved is the Lorentz transformation. So the crux of the issue for today is this. In his 1905 paper, Einstein asserted that because the theorem of Pythagoras is form invariant under Lorentz transformation, his expanding spherical wave of light centered at the origin of coordinates of his stationary system is transformed into an expanding spherical wave of light centered at the origin of coordinates of his moving system. However, this claim is false. Form invariance of the theorem of Pythagoras under Lorentz transformation simply shows that the distance from the origin of a coordinate system to the electromagnetic wavefront is given by the right triangle rule in both of Einstein's systems of coordinates. It is false that form invariance of the theorem of Pythagoras under Lorentz transformation implies form invariance of geometric shape of that electromagnetic wavefront. That the distance from the origin of a coordinate system to some other point is always given by the theorem of Pythagoras does not fix the shape of an electromagnetic wavefront. This fact alone is sufficient to prove that the special theory of relativity is false. In this video, the invalidity of special relativity will be proved in three equivalent ways. The first method is the simplest because it just consists of plotting points. The second way is algebraic in terms of Cartesian coordinates, and the third way is algebraic in terms of polar coordinates. Let's first review the Lorentz transformation. In his 1905 paper, Einstein used Roman letters for his stationary system and Greek letters for his moving system. In this way, here, x, y, and z are the Cartesian coordinates for the position of a point in his stationary system at some time t. V is the constant speed of his moving system, which is written in the corresponding Greek letters, also denoting Cartesian coordinates. C is the speed of light. A revealing form of the Lorentz transformation is obtained by eliminating x from the first equation by using the second equation to give this set of equations. One can now see from the first of these equations that for any particular time t for the stationary system, the time τ depends upon the position xi in the moving system. In the stationary system, the time t does not depend upon position. Following Einstein's notation, I denote the stationary system by uppercase K and the moving system by lowercase k. In order to reduce clutter from the analysis, I'll consider an expanding circle of light rather than a sphere of light. It's very easy to apply the symmetry between the y and z axes to generate the three-dimensional from the two-dimensional when we need to do so. With the z and zeta coordinates suppressed, here is Einstein's scenario. After a time t, the expanding spherical wave of light in the stationary system K, here a circle in the xy plane, has radius r equals c times t. According to Einstein, the wavefront in the moving system, lowercase k, under Lorentz transformation, is also spherical, centered at the origin O', and has the radius ρ equals c times τ. At time t equals τ equals 0, the two systems are superposed, so that their origins coincide when the light is initially emitted from the origins in all directions. Note that the origins O and O' are separated by the distance d equals v times t, according to the stationary system K. Furthermore, since v is less than c, O' lies on the x-axis within the circle of light in the stationary system K. The figures therefore always overlap, but they have been separated here for clarity of presentation and analysis. Now when t equals 0, the distance d between the two origins of coordinates is 0, and the origins sit on top of one another. Note that the x and z axes are collinear in this arrangement. To see why Einstein's conclusion is erroneous, let's look carefully at the two equations he presented for his alleged spherical form invariance under Lorentz transformation. Here they are again. These two equations have exactly the same form. In other words, the theorem of Pythagoras is form invariant under Lorentz transformation. Now, since the first equation describes Einstein's expanding spherical wave of light centered at the origin of his stationary xyz coordinate system by construction, Einstein concluded that the second equation also describes an expanding spherical wave of light centered at the origin of his moving xi, eta, zeta coordinate system. In both equations, the speed of light c is exactly the same. In other words, the speed of light is invariant. But note that both of these equations are statements of the right triangle rule, that is, the theorem of Pythagoras. These equations merely state that the distance from the origin of coordinates to the wavefront is given by the theorem of Pythagoras. They don't say or imply that the spherical electromagnetic wavefront constructed in the stationary system K remains a spherical wavefront in the moving system, k, under Lorentz transformation. Neither do they say that the center of the transformed wavefront in the moving system is located at the origin of that coordinate system. Einstein incorrectly assumed that form invariance of the theorem of Pythagoras under Lorentz transformation is also form invariance of the spherical shape of his expanding wave of light, and that his transformed wavefront is also centered at the origin of the moving coordinate system. But that does not follow. It is in fact false, as I will now prove. In order to avoid calculating with large numbers, set the speed of light to unity. Then the speed v of the moving system can have values in this range. We can map the spherical wave in the stationary system into the moving system at any convenient time t. So set time t to 1 unit. With these values of c and t, consider now the origin x equals 0, y equals 0 of the xy plane and the 4 intercept points on the xy axes of the spherical wave of light in the stationary system K. Thus, this can be represented in this diagram. Note that the origin of coordinates is also the center of the sphere. To see how things transform, I'll start with the speed v equals 0.1. The Lorentz transformation is then given by these equations. Let's now compare the corresponding points and times in both systems. Here they are. Here is a graphic for this result. Note that the time τ in the moving system k varies with the position xi therein. Also note that the origin x equals 0, y equals 0 of the xy system is not transformed to the origin of the moving system, but to the point with coordinates xi equals minus 0.1005, eta equals 0. This on its own is sufficient to prove special relativity false because the origin of the coordinate system is not transformed to the origin of the moving system under Lorentz transformation, contrary to Einstein's claim. In the stationary system, the origin of coordinates and the center of symmetry coincide, but in the moving system they do not coincide under the Lorentz transformation. In fact, the center of symmetry of the wavefront in the stationary system is mapped into the center of symmetry of the wavefront in the moving system. Note that the wavefront in the moving system is not a circle. It is a translated ellipse, and its center is not at the origin of the moving system, but at the point with coordinates z equals minus 0.1005, eta equals 0, which is the center of the ellipse. That is, the center of the expanding circular wave of light in the stationary system, which is also the origin of coordinates of that system, is mapped to the center of the expanding elliptical wave of light in the moving system, which is not at the origin of coordinates of the moving system. Note further that the translation is into the negative horizontal axis of the moving system, and that the point d equals v times t on the x-axis of the stationary system is mapped to the origin of the moving system. In other words, the point with coordinates x equals vt, y equals 0 in the stationary system is mapped to the origin z equals 0, eta equals 0 of the moving system. What about the time tau at the origin O prime of the moving system? It has this value. What about the theorem of Pythagoras? Let's calculate the distance ρ from the origin of the moving system to the elliptical wavefront for each of the points that have been plotted. There are two ways to do so: by using the coordinates in the theorem of Pythagoras and by multiplying the time tau associated with each point on the wavefront by the speed of light. The speed of light is exactly the same in both systems. Here is the result. Note that in all cases this equation holds. Consequently, in 3 dimensions this equation holds. Thus, the theorem of Pythagoras holds even though the transformed spherical wavefront is a translated ellipsoidal wavefront. So Einstein's claim that it is also a spherical wavefront centered at the origin of the moving system is false. Repeat these calculations with v equals 0.5. The Lorentz transformation is given by these equations. Now compare the corresponding points in both systems. Here they are. The time tau at the origin O prime of the moving system has this value. The center of the translated ellipse in the moving system has these coordinates. Here is the graphic for this result. What about the theorem of Pythagoras? Let's calculate the distance ρ from the origin of the moving system to the elliptical wavefront for each of the points that have been plotted. Here is the result. Note that in all cases this equation holds. Consequently, in 3 dimensions this equation holds. Thus, the theorem of Pythagoras holds even though the transformed spherical wavefront is a translated ellipsoidal wavefront. Therefore, Einstein's claim that it is also a spherical wavefront centered at the origin in the moving system is false. Now repeat these calculations with v equals 0.9. The Lorentz transformation is given by these equations. Compare the points in both systems. Here they are. The time tau at the origin O prime of the moving system has this value. The center of the translated ellipse in the moving system has these coordinates. Here is the graphic for this result. What about the theorem of Pythagoras? Let's calculate the distance ρ from the origin of the moving system to the elliptical wavefront for each of the points that have been plotted. Here is the result. Note that in all cases this equation holds. Consequently, in 3 dimensions this equation holds. Thus, the theorem of Pythagoras holds even though the transformed spherical wavefront is a translated ellipsoidal wavefront. Therefore, Einstein's claim that it is also a spherical wavefront centered at the origin in the moving system is false. Note that from all these graphs it is evident that the eccentricity of the ellipsoid increases with increasing speed v. What is the equation of the ellipsoid in the moving system, little k? This can be determined from the Lorentz transformation in both Cartesian coordinates and polar coordinates. I'll start with Cartesian coordinates. Here is the expanding sphere of light projected onto the xy plane of the stationary system K. Since the position of the wavefront on the positive x-axis at any instant of time t is given by this expression, every position on the positive x-axis within the sphere of light at any time t can be specified by this expression, where n is a real number greater than or equal to 1. A similar expression accounts for the negative x-axis within the sphere of light. The theorem of Pythagoras then gives this equation. Recall the first form of the Lorentz transformation. Here it is again. Putting the foregoing expressions for x and y in terms of n into the Lorentz transformation gives this set of equations. In these equations, ρ is the distance from the origin O' to the wavefront in the moving system. Solving the Xi equation for n gives this expression. Putting this value for n into the last equation for eta and rearranging gives this equation for the ellipse in the moving system. Thus, the expanding wave of light in the xy plane of the stationary system K is circular, but by Lorentz transformation is a translated ellipse in the xy-eta plane of the moving system k, and is centered at this point. Note that the center of the translated ellipse is not stationary because it changes with the passage of time t. Consequently, as the ellipse expands, its center moves away from the origin of coordinates of the moving system into the negative of the horizontal axis. Owing to the symmetry between the eta and zeta axes, the translated ellipsoid has this equation. The intercepts on the coordinate axes of the moving system are easily obtained. Here they are. Denote the time at the center of the translated ellipsoid by tau sub c. Then, by the Lorentz transformation, it is given by this expression. Then the equation of the ellipsoid is given by this expression, and the intercepts are then these. What about the theorem of Pythagoras? It gives this expression for the ellipse. Using the time tau sub c at the center of the translated ellipsoid gives these equations, from which it is easily seen that this expression results. So the theorem of Pythagoras always holds. Recall that by the second form of the Lorentz transformation, there is a relation between the time tau and the position xi in the moving system for any given time t. Here are those equations of the Lorentz transformation again. Consequently, the equation for the ellipsoid can be written in terms of any time tau corresponding to any particular time t. For example, denote the time at the origin of coordinates of the moving system by tau sub o. Then by the Lorentz transformation, it is given by this expression. Then the translated ellipsoid is given by this equation. Using the time tau sub o at the origin of coordinates of the translated ellipsoid gives these equations, from which it is easily seen that this expression results. So the theorem of Pythagoras always holds. All such recasting of the equation of the ellipsoid for a time tau according to position xi describes exactly the same ellipsoid, and in all cases ρ is the distance to the wavefront from the origin of the coordinate system, in accordance with the theorem of Pythagoras. I'll now derive the equation for the ellipse in the moving system in terms of polar coordinates under Lorentz transformation. Denote the angle made by r with respect to the positive x-axis for the circular wave of light in the xy plane of the stationary system by theta. Then the Lorentz transformation gives this set of equations. Now denote the angle made by ρ with the positive xi-axis for the elliptical wave of light in the xi-eta plane of the moving system by theta sub ρ. Note now this simple relation. Therefore, the relationship between theta and theta sub ρ is given by this expression. Observe that this relation depends only on the speed v. Now solving this expression for cos theta gives this expression. Putting this expression into the Lorentz transformation in polar coordinates gives this equation for ρ. Recall this relation for the time tau sub c at the center of the ellipse. Then the expression for ρ becomes this. This is the equation for the translated ellipse in polar coordinates ρ and theta sub ρ in terms of the time tau sub c at the center of the ellipse. Once again, by the Lorentz transformation, the polar coordinate expression can be recast in terms of any time tau associated with any position xi, and the resulting ellipse is exactly the same. Furthermore, in all cases, ρ is the distance from the origin to the wavefront. For example, again, denote the time at the origin of the moving system by tau sub o. Then, by the Lorentz transformation, the equation for the translated ellipse in polar coordinates takes this form. Since Einstein asserts that only relative motion exists, both of his inertial frames of reference must see the very same expanding spherical wave of light. If not, then the laws of optics are not the same in each system of coordinates, contrary to his first postulate of special relativity as to the laws of physics, namely his principle of relativity. Recall Einstein's remarks in the introduction of his 1905 paper. Here they are again. The same laws of electrodynamics and optics will be valid for all frames of reference for which the equations of mechanics hold good. We will raise this conjecture, the purport of which will hereafter be called the principle of relativity, to the status of a postulate. According to Einstein, only the Lorentz transformation enables his two postulates of special relativity to be satisfied. In his book with Infeld, The Evolution of Physics, Einstein says this: only one transformation from one coordinate system to another can exist, the Lorentz transformation. In conclusion, it is essential for Einstein's theory that the Lorentz transformation does not change the shape and center of symmetry of his expanding spherical wave of light. But a spherical wave of light centered at the origin of coordinates of Einstein's stationary system is not transformed into a spherical wave of light by the Lorentz transformation. Einstein's assertion that form invariance of the theorem of Pythagoras under Lorentz transformation also means form invariance of the shape of his expanding spherical wave of light is false. Under Lorentz transformation, his spherical wave of light becomes a translated ellipsoidal wave of light that has a moving center of symmetry, which is not located at the origin of coordinates of his moving system. The Lorentz transformation upon which Einstein constructs his theory does not in fact satisfy his postulates. His special theory of relativity actually violates the Lorentz transformation itself. The special theory of relativity is therefore false because it violates the rules of geometry. If you'd like to study all the mathematical details, you can consult these papers. In the next video, I'll present proof that Minkowski's construction of the four-dimensional spacetime continuum is invalid because it violates the rules of geometry. He merely replicated Einstein's violation of geometry in a different way. That is all for today. If you enjoyed this video, promote the channel. Mention the videos to your friends and to your local astronomy club. Support with a like or subscribe for more videos as we look more closely at the sun, the stars and beyond. Comments are always welcome down below, and I'll see you soon in my next video.